this lesson, we're going to be talking about volume of rectangular prisms, and we're going to look at specifically, after our initial example, some examples with fractional edge lengths. But let's get ourselves warmed up. The first example here shows a rectangular prism, and it shows the length, width, and height, and it doesn't really matter which way we call that, because of course we could, stand this box up on its end, and then you might call length, width, and height something else. But those are the three different dimensions of this rectangular prism. So from the formula sheet for the PSSAs and that I would provide to you, the volume for a rectangular prism is length times width times height. We don't need to write any multiplication symbols. Variables next to each other mean multiplication. Okay, so we just need to basically plug these in, and it doesn't matter which order because multiplication is commutative. So plug in 10, 4, and 6. I like to put parentheses for the multiplication. So 6 times 4 is 24, times 10 is 240. Now, one thing that we need to remember, we start off with inches, and we multiply inches by inches by inches. So just like 2 times 2 times 2 is 2 cubed, and x times x times x is x cubed, inches times inches times inches is inches cubed. You could call them cubic inches, but for three-dimensional shapes, the volume is to the power of, the units are to the power of 3. That doesn't mean 240 is to the third power. It just means that the units are cubed units, which would ultimately mean that if we found cubes that were 1 inch in every direction, and we tried to pack this shape with these tiny little cubes, we could fit 240 of those 1 inch by 1 inch by 1 inch cubes inside of this rectangular prism. Okay, let's just do another one, just get ourselves comfortable. Please write the formula every time, length, width, height. So volume equals 8 times 5 times 12. Okay, multiply all three of those together, and we get 480 inches cubed. Terrific. All right, let's look at a slightly more interesting problem, because that's pretty straightforward. We need to multiply three numbers together. We get the volume. Okay, so it says a box with the same dimensions as the prism in the opening exercise is used to ship miniature dice whose side lengths have been cut in half. The dice are 1 inch by 1/2 inch by 1/2 inch by 1/2 inch cubes. How many dice of this size can fit in the box? Whoa. So there's two approaches to this. So the first approach, let's find the volume of the dice. I'm going to call that volume of dice. Make a little subscript of dice. You don't have to do that, but that'll keep it clear for me. So that is length times width times height again. So the volume of the dice is 1/2 times 1/2 times 1/2. And for some reason, I do see people mess this up. I think they start adding or something like that, but you're not going to do that. So you're going to multiply the numerators, get 1, multiply all the denominators, get 8, and that's 1/8 inches cubed. Terrific. Okay, so that's the volume of one of these little dice. So the volume of the whole shape, we remember, was 240 inches cubed. So how can we figure out how many 1/8 inch cube objects, in this case dice, would fit in there? Well, we can go ahead and divide the 240 by the 1/8 inch cube. And how do we divide fractions? We take the number and we multiply by the reciprocal. So 240 times 8 would give us 1,920 dice could fit inside this box. Wow, that is a lot of dice. Another way that we could approach this, if we look at the dimensions of the original figure, 1/2 by 1/2 by 1/2, and we look at the dimensions of the original prism. So the 10 inches along the bottom here, how many dice could we line up if we tried to pack them across the bottom? Well, since they're 1/2 inch and there's 10 inches total, we could fit 20 dice across the bottom. By a similar fashion, we could fit 8 8 dice deep and 12 dice high. So it's not exactly a volume calculation, but it sort of is. So if we think of it as 20 by 8 by 12, we would still get 1,920 dice that we could fit in this rectangular prism. Okay, so let's just look at a straightforward prism volume, but this time we have fractional lengths. On the PSSAs, this could totally be a question that was asked without a calculator, because multiplying fractions is a skill that you're supposed to be able to do by hand. So if we go ahead and try to find the volume, I'll write down the formula first. Volume equals length times width times height. First, I'm just going to plug them directly in as, well, no, I'm going to go over here. I'm going to convert them right away. So 1 1/2, that is 3 halves. 1 can stay as 1, and 3 3/4. Remember, 3 times 4 is 12, plus 3 is 15 fourths. So these are the numbers we're going to plug in. So volume equals 3 halves times 1 times 15 over 4. Okay, I wish there was some great cancellation we could do here, but there's really not. So the denominator is 2 times 4, so on the bottom we have 8, and on the top we have 45. For my purposes, I'm fine with 45/8 inches cubed, but if this is a multiple choice test and we needed to pick the correct answer here, we could go ahead and figure out how many times 8 goes into 45. So 8 goes into 45 times, and would leave us with 5/8 over. So those are our two possible ways that we could represent the volume of this rectangular prism. So that's basically how we would find the volume of a rectangular prism, even with fractional lengths, or how we might even find how many of one prism would fit inside of another prism.